You're listening to Don't Waste Water.
What we have invented is a brand new membrane. And really, this is the first time we've had a whole new membrane material applied to reverse osmosis in over 40 years.
Hello, bonjour, and welcome to the Don't Waste Water podcast.
My mom called me and she said, guess what? I said, what? She goes, I fixed the problem with the sulfonated polysulfones for reverse osmosis. And we filed a patent today. And I just like a light bulb went off. And I said, that's it. I said, I think we should make chlorine-tolerant reverse osmosis membranes. What do you think? Do you want to start a company with me?
I'm your host, Antoine Walter, and in today's episode, I'm delighted to welcome Sue Mecham as my guest.
We spent 5 years figuring it out, and we were told, I can't tell you how many times, that it can't be done. Many professionals in the industry have said, I tried it, I couldn't get it to done. It's not going to work. You can't do it.
Sue is the CEO and co-founder of Nala Membranes.
Let me find the dirtiest water, the hardest situation we can possibly throw at this. And many times they're just coming back just flabbergasted because then that was amazing. That got completely fouled up and we cleaned it off and it just kept on running and we did it over and it keeps on going.
Nala Membranes develops and produces a new generation of chlorine-durable reverse osmosis membranes in a drop-in form factor.
We're not looking to raise a huge round. We're looking to raise another small round. So we're looking to raise another 5 million. And we feel that 5 million is going to position us for potentially a bigger round at that point, for potentially what we would call a Series A that, might be 10 to 20 million.
And before we start, let me thank my sponsor, Simple Lab.
If it's going to make the kind of difference that we think it's going to make, which is going to reduce the cost overall of reverse osmosis, make it much less complicated, make it lower environmental impact, those kinds of things are going to really enable reverse osmosis to do what it has the potential to do, which is solve the world's water crisis. It really does. But right now, it's too expensive and it's too limited and it needs to get better.
If you're in the water sector for at least a couple of years, I'm sure you can recall at least one occurrence of the following story. As we discussed the early days of Nala Membranes with Sue, she told me how she had brought her newly found material to some of the established membrane big guys. There, she met with technical people first, and to quote her,
their technical people said, I think this has a lot of potential. I think we could probably do something with this. And the business side of that said, nope, we're not going to do that.
As Sue rightfully analyzes,
there's no incentive to disrupt their very stable, steady market.
It happened to me, and I would bet you have been someday on one or the other side of that conversation, right? Actually, this is a very well-documented behavior, notably by Clayton Christensen, who coined it as the innovator's dilemma. To put it simply, successful companies get really good at making their existing products better for their best customers, and this creates a trap. They ignore new technologies that initially suck but serve different needs or markets. The other side of that same coin is that by the time those inferior technologies improve enough to threaten the main business, it's too late. The newcomers have built their whole operation around the new approach, while the established company is still trying to protect its old cash cow. Or at least, that's the theory. Because yes, there are well-documented examples of that going exactly by the book. Kodak turning down their engineer who had figured out the world's first digital camera, Blockbuster letting Netflix do their streaming thing while they double down on the money-making physical copy rental, or Xerox turning down personal computing, Western Union laughing at the telephone, and AT&T saying no to the radio. This would make you believe that, hey, you got turned on by a major, no big deal, just do your thing, and in 10 years' time, you'll laugh about it while sipping a cocktail in the back of your limousine while going to the auction of the remains of the former giant's assets. Like, that's a sure thing, disruption is inevitable if you have a superior technology. Except, that sounds like a survivor bias at best, a total illusion at worst, even more so in water endeavors. Think of it, does anyone really believe that Internet Explorer was at any point in time the best browser in the world? Yet, in the early 2000s, they had a nearly 96% market share. The Betamax was a better format than VHS tapes, but once Blockbuster had stocked VHSs by the thousands, and distributors had embraced the format, who was gonna make the switch for the slightly better alternative? And we still use QWERTY keyboards, despite clear proof that the Dvorak layout is 75% faster, but hey, once you've learned to type, switching is so difficult that who would seriously do it. And I'm personally using a German quartet keyboard, so I know what I'm talking about when I say that I'm resistant to change here. This is the privilege of the incumbent. The resistance to change and the power of the status quo are so strong that taking them out is much harder than what we too often think. Academic research places the bar somewhere between 15 and 30% market penetration, which you need to reach to achieve irreversible adoption momentum. And sure, then it goes faster, as getting you to 40 to 50% market share is an almost certain way for winner-takes-all stories like Kodak or Blockbuster. But once you're there, you really earned it. So what I'm saying here is that it's not easy to disrupt an incumbent, but has it ever been done in water tech? Well, good news, yes. Bad news, not often. I mean, Trojan did it with UV disinfection. By 1977, they were a 3-person startup in Canada, developing an alternative to chlorine most people laughed off. But by the early 2000s, UV was finally regulated and accepted in municipal water, and today it is clearly mainstream. Another example is the pressure exchanger that allows the recovery of up to 60% of energy in desalination plants. It was introduced in 1992 by Energy Recovery Inc., and it became mainstream by the mid-2010s. Today, 70 million people drink water that goes through a plant equipped with the device. And obviously, there's the canonical example with Xenon's patient push of the membrane bioreactor through the 80s and 90s desert, for it to finally become mainstream in the 2000s, especially through the GE acquisition in 2006. So, disruption is possible, but it's not the easy path. If you want the full breakdown of what it takes, you know which book I'm gonna recommend. If you'd rather watch, I made a video on the topic, the link is in the description. But the reason I wanted to underline all of that is that when you're taking the road to disruption, you're really embarking on a journey. It's not an easy path, and it will require more than just great technology. It's a story of grit, passion, execution skills, and people skills. This is, by the way, why I have an absolute fascination for water tech entrepreneurs. They are unsung heroes and absolute powerhouses of inspiration. And you'll get a killer example of just that once that leaves through the floor. Trust me, it certainly takes a specific type of people to make it to the shortlist of water disruptors. But as I told Sue in our conversation, she didn't know it was impossible. That's why I really believe she has a shot at achieving it. As always, if this is of value to you, it may also be for a friend, a colleague, your boss, or your team. So share it with them, and I'll meet you on the other side. Hi, Sue. Welcome to the show.
Thank you.
I'm looking forward to that conversation for a full set of reasons. I have seen you on trade shows, and I have to say I need to get clever about your technology and what you do, because all your pitches sounded astoundingly interesting. I like to go straight into the problem you're solving, which is that reverse osmosis has this drawback that it doesn't stand chlorine that much. And as a result of that, whether you break it by putting chlorine on it, or it fouls and it clogs. And that's where you come in. So what's the trouble today? How do people behave if they don't use nanomembranes? And how do you solve that in a unique fashion?
I appreciate the question, Antoine. I will be clear that I am not a water systems person. I am a polymer chemist, and we came at this development of this new membrane technology based on what we had heard was a problem in the industry. And when I really started digging into the terminology I heard was chlorine-tolerant membranes are the holy grail. And I went, oh, okay, well, let's see what we can do about that. But then I started to dig a little bit more. Why do they want chlorine-tolerant membranes? And what it really got down to, what everyone talked about, was biofouling, and how biofouling was really a huge problem for the industry. I talked more about it. I looked up. There's studies that demonstrate what a huge impact biofouling has on operating costs for reverse osmosis systems. And when you talk to people, most of the time, they agree with that issue. And so the concept of chlorine is using chlorine to eliminate biofouling and deal with organic fouling that can happen with membranes. You put chlorine in a pool in order to keep algae and green things from growing in your pool, right? Everybody knows that. But what a lot of people don't know is you can't do that in a reverse osmosis system today because the membranes are very easily damaged by that chlorine bleach. And so what they're looking for is an opportunity to be able to get rid of biological growth, just like you do in a pool. Let's do that in a reverse osmosis system and protect those membranes from all of that fouling. And so the idea that we came up with nanomembranes was to develop a chlorine-stable membrane where we could use a low level of chlorine in the system to completely eliminate biofouling. And what we found as well as we go into more wastewater applications is that a lot of water has organics in it already. And so the chlorine, it can also be used for cleaning membranes when they get fouled with organics. And so the beauty of our membranes is you can use a low level of chlorine to eliminate biofouling, or you can use a high level of chlorine to clean off the organics and get the membrane back up and operational. And that's because they're really very stable to chlorine.
That means that we have this association, reverse osmosis designation, that's pretty baked in our water brains. But when it comes to wastewater reuse, it's also reverse osmosis that you're going to use. And there you'll have different stuff which comes across the membrane. And that's where you would use the high chlorine to solve that.
Correct.
Can you just define what is low and high so that we have like a good idea what we're discussing here?
Sure. Low levels of chlorine to manage biofouling. If you go back into the history of reverse osmosis membranes, cellulose acetate membranes were used originally for reverse osmosis, and they had some low level of chlorine stability. And so it's been demonstrated with those membranes in the years past that you could use, half a ppm to 1 or 2 ppms of chlorine and completely eliminate the biofouling issue in many systems. And so what I would call a low level is, say, something under, say, 5 ppm, something like that. And that's typically what you would see in drinking water as well, in terms of keeping bacteria and things out of water. They would put in, a few ppm of chlorine to eliminate that. So that's what I would call a low level. Now, a high level, some people might say, 100 ppm would be a high level, but sometimes that's just not enough to clean off those dirty membranes. And so you might have to use 1,000 or even 10,000 ppm of sodium hypochlorite to clean off a really dirty membrane. And we've demonstrated that's perfectly possible with nanomembranes.
So you can go up to 1,000, 10,000, and the membrane is just saying, okay, no problem, business as usual.
Exactly.
I think that's a better or an expanded definition of how you have the Holy Grail, maybe. So interesting one. What I found out also looking at your documentation is that not only do you have this ability to withstand chlorine, but you also have a smoother surface on the membrane, which again, if you want to combat biofouling, needs to stick to something. If it can't stick, then you have an increased advantage. So what makes your membrane smoother?
Well, let's see. We're going about this in small pieces. There's a whole reason why we've ended up with this new membrane. And so if you let me take a step back and just describe, say, what we have invented is a brand new membrane. And really, this is the first time we've had a whole new membrane material applied to reverse osmosis in over 40 years. And that's really coming off the polyamide membranes that are the basis of the market today. But originally there were cellulose acetate membranes, and those cellulose acetate membranes were, like I said, slightly chlorine stable because it was a different material than the polyamide. And they also had a smooth surface, and that was a function of the manufacturing process that was used to make them. And those were both advantageous characteristics that went by the wayside with the polyamide thin film composite. Because of the way the polyamide thin film composite is manufactured, you obviously have a polyamide as your separation layer, but you also have a very rough surface. And that's a function of the manufacturing process that's used to make it. So it's inherent to that type of membrane. The same thing goes with our membrane. So we have developed a brand new material that we're using, the sulfonated polysulfones. And we've invented a new manufacturing process to create a thin film composite in a different way than they create the polyamide thin film composite. And our manufacturing process leaves a smooth surface. And so we have those kind of idealized characteristics of the cellulose acetate membrane that we've brought to the thin film composite construction with our sulfonated polysulfones. That gives it that mechanical resistance to fouling, as well as the material stability to chlorine. We also have additional factors related to the pH stability of the material, but it is a more ionic surface than you see with the polyamide membrane. We've got sulfonates there. These are sulfonated polysulfones. And so those sulfonate ions are going to reject organics as well as ions in a different way than the polyamides. So it really is a new membrane material, and it needs to be thought about that way. It's not just a chlorine-stable polyamide thin film composite. It's a sulfonated polysulfone thin film composite. It's a different membrane. It's going to have whole new applicability because it's a different polymer. It's a different chemical structure. So I just want to kind of bring that out at the beginning to say, look, both the material and the manufacturing are critical. And those are the innovations that we've brought to the membrane industry.
There's a lot to deconstruct in what you just said. So we'll break it down.
Yes.
Just I want to make that last point clear before we break it down. You mentioned how it's a new material. We had conversations on that microphone with Aquaporin, with Evolve, which are coating membranes. You're not coating, you're making full-blown membranes. So that out of the way, the first thing I want to break down with you is that you say we, but usually when people say we, it's me and my team. For you, it's a bit special because we originally is you and your mother. I think when I discussed with Peter Yolds, he was mentioning father-daughter duo, which is one of the companies he's invested in. But you're, to my knowledge, the only mother-daughter duo in water entrepreneurship. So that all starts, according to the legend, in a conversation you're having with your mother. So tell me about that conversation and how from that conversation do you go to creating a company within 1 week?
Of course, there's a lot of backstory to that 1 week, right? And that backstory, really is a kind of the story of my life and how I grew up. When I was a child, my mother and my stepfather were entrepreneurs. And so they had businesses. I grew up in businesses. I think before I was 13 years old, I spent time in 2 clothing stores, a sub shop, a restaurant, a health spa, and a bar. And that's how I grew up. This is around businesses. And so I always thought, hey, this is the way life should be. But then when I was a teenager, my mother finished graduate school and became a PhD polymer chemist and went out into the world and started working at a startup, actually, out in California, where I went to high school. And I watched her kind of become this technical leader in this small company and making big changes and inventing new materials it was for a medical device application. And I just thought that was super exciting. And as a teenager, I'm trying to decide to go to college. I said, you know what? That looks like that's working out really well. I'm going to get my PhD in polymer chemistry. So I did. And because that's what I do. I set a goal and I go do it. And so I did. And, as the years went on, my mother was a professor at Virginia Tech very successfully. I think she had 60 something PhDs come out of her group over the years. I kind of went down that path, but I really never wanted to be an academic professor. I wanted to go in industry. I liked making things. I worked for a company that manufactured things. I enjoyed that, but I also like being a technical leader. And long story short, on my career in industry, I came to the end of about an 11-year career in industry and said, you know what? I want to start my own company. I could do this so much better if people are doing this. But I said, I don't know what I want to do. I knew I wanted to do something in polymers because that's my expertise. And I knew I wanted to do something important because I didn't want to just make a widget. That wasn't, I wanted to do something that was really important. And for a long time, I really thought it was going to be in the medical device space. And when I left industry, I went back to academics as a research scientist. And I ran a research group at Virginia Tech for Jim McGrath. And then I transferred down to North Carolina and I ran a research group at the University of North Carolina for Jody Simone. And the whole time I was doing that, I was looking around, how am I going to start a company? What am I going to do? Where's the opportunity going to be? I almost went with a medical device out of UNC and backed out at the last minute. What didn't feel quite right. And not too long after that, I'd say a few months after that, my mom called me and she said, guess what? I said, what? She goes, I fixed the problem with the sulfonated polysulfones for reverse osmosis. And we filed a patent today. And I just like a light bulb went off. And I said, that's it. I said, I think we should make chlorine-tolerant reverse osmosis membranes. What do you think? Do you want to start a company with me? And she hesitated for a minute. She said, yeah, let's do it. And so here we are.
Let's hear from my sponsor, Simple Lab. Testing water and everything around it should be simple. With Simple Lab, you choose what to test, from drinking water and wastewater to soil, air, food, and surfaces, and they handle the rest. Kits arrive at your door with free round-trip shipping, samples go to certified labs, and results come back fast, concise, and actionable. Trusted by leading brands and growing teams, Simple Lab offers hundreds of ways to better understand your environment. Get started today at gosimplelab.com. It's the first link in the description. Thanks Simple Lab for supporting my work, and back to me. But you made clear in your introduction that there is 2 elements to it. There is the material and there is the manufacturing.
Correct.
That is the material. How do you get to the manufacturing?
Yes, that's absolutely right. That's the material. And so in, developing reverse osmosis membrane materials, she was from Virginia Tech collaborating with the University of Texas at Austin, Professor Benny Freeman's group, and Don Paul as well. And through those collaborations, is how those materials got developed. And so we kind of knew we had a good material to work with. But what we also knew, and there's a science paper that came out a couple years ago that I like to reference, but this was before that. But we were very aware of the fact that new membrane materials had been proposed before. And there were, lots of ideas for, hey, here's this new material to make a great membrane. But nobody could figure out how to make it on a large scale very rapidly, which you have to be able to do for reverse osmosis membranes. And so that was the very first challenge we faced. And so I remember her and I sitting and looking over papers and technical specifications and trying to figure out how are we going to make this polymer into a functional membrane. And we knew that there were kind of a couple of different approaches that we thought would work. One was basically the phase inversion process that was used to produce the cellulose acetate membranes in the past. That was a possibility for us. The other possibility would be a thin film composite construction. And so then we'd have to figure out how to do that. And so we knew that was our challenge, and we took all of our kind of studies on that, and we submitted a proposal to the National Science Foundation for an SBIR grant to begin working on that manufacturing process, because we had the material. And so then we really started NALA, and the whole focus of NALA was how are we going to make it, right? That was our big focus. And we spent 5 years figuring it out. And we were told, I can't tell you how many times, that it can't be done. Many professionals in the industry have said, I tried it, I couldn't get it to done. It's not going to work. You can't do it. Oh, well, we're going to keep trying. And yeah, we've had great success with that.
But that is not intuitive. I mean, when you're starting NALA, in another life and another path, there would be an option where you say, you know what, we have the polymeric knowledge and we can support a company doing the actual manufacturing, and we can even help them develop it. But they already have the factories, they already have all those lines, and they might be better placed to do that because, membranes is always that field which is close to tech, because once you get it adopted, then you have a repeat business and then you have recurring revenue. But the hurdle to get in is pretty high because you have a lot of capex involved in building plants, in building manufacturing capability. So why did you choose the hard mode and not the easy mode?
Well, there's probably multiple answers to that question. But one of them is that back in about the 2010, 2011 timeframe, when Jim McGrath was still running the sulfonated polysulfone development work, he was working with Benny Freeman, and they had a grant from one of the major membrane manufacturers. And they handed over some materials, and that company developed an asymmetric membrane and did some tests. This was the material prior to the one that Judy invented. So it wasn't maybe quite right, but their technical people said, I think this has a lot of potential. I think we could probably do something with this. And the business side of that said, nope, we're not going to do that. That was the innovator's dilemma. There's no incentive to disrupt their very stable, steady market. And so we knew going into this that we were going to have to do it ourselves. We were going to have to prove it, and we were going to have to show them how good it could be, because the industry wanted it, the manufacturers didn't. And we were going to have to go around that to get to the industry, because the industry wants it badly.
Let's maybe define that, because the industry wanting things is one thing. The industry then walking the talk and getting to adopt things is something else. And I know that you've been on the Blue Tech pavilions at several trade shows, so you know pretty well the theory of Paul Callahan around how long it takes to adopt hardware in the sector. And people always complain that, that's looking at the past, not at the present, but the core of it is around membranes. So I think it's pretty accurate when it comes to membranes. So where I'm heading with that is that, let's just throw numbers into the game, because there's this saying in the water industry that if you're not at least 20% better than the incumbents, you don't have any place under the sun. So what would be your estimate on a key parameter like operating costs? How much better would the industry be with your solution?
We still have a lot of things to add to that, but I would say that the low-hanging fruit is a very nice study, a techno-economic analysis that was done to measure the impact of biofouling on operating costs for reverse osmosis systems. And the average value that they came up with was 24%. And so if we can eliminate biofouling using a small level of chlorine, then right off the top, that's 24% operating cost. And that's energy, chemicals, cleaning and labor for cleaning, as well as membrane replacement. So all of those factors fed into those values. Now, I think there's a lot of other opportunities for savings, and I think that we're working towards developing those. But it's not just operating costs. We're also looking at potential capital cost savings for new builds. So for existing systems, you can't do much about the capital, but for new builds, we have the potential, because these membranes are very easily cleaned, they're lower fouling, they're, much more stable and durable, of reducing or even eliminating some of the pretreatment steps, and certainly some of the redundancy, and certainly some of the cleaning operations. And so the savings in capital costs is still certainly TBD, and the total savings in operating costs is also TBD, but I would say that we're talking about a minimum of 24%.
So you beat the door, which is like that 20% is what you need to get to. You're above that. So that's one hurdle out of the way. You mentioned how the industry wants it and the manufacturers don't really want to disrupt what's working. I mean, if it's working, why fix it? How do you get to your first industry encounters, pilots, deployments? So what's the trick there?
One of our challenges for us is we're not water people. We're not membrane people. Of course, we've been adding to our team, but there's a lot of work to be done to understand what is the best way to operate a membrane system using our membranes. There's a lot of work to be done there in the field. We've just moved from the laboratory to the field, and it's a very different, capabilities from the laboratory to the field. And so there's a lot of work still to be done there. One of the opportunities that we have had, though, is the ability to sell membrane sheet to customers that make their own elements, they make their own systems, they maybe have custom designs of their elements. And so the idea here is they're the real innovators. They're the ones that are looking for ways to solve the problems for the customers in the industry. And they're seeing our membranes as a brand new tool that they can use and begin to apply. And it's funny because we'll send out a membrane to someone for them to evaluate our membrane sheet. And of course, at least the ones we go to, they want to put it in the most challenging operation they can find. They're like, let me find the dirtiest water, the hardest situation we can possibly, throw at this. And many times they're just coming back just flabbergasted because then that was amazing. Like that got completely fouled up and we cleaned it off and it just kept on running and we did it over and it keeps on going. And that's what we like to hear, that they like what we have. And then we can work with them to say, okay, so because of the fact that we have control over our materials, we have control over our manufacturing process, what properties do you want? What do you want in terms of a flux and a rejection? What are you trying to do with your applications? And so we're beginning to develop products based on what customers are telling us they want and how they can be used. It's actually a really fun part of this journey, is really beginning to see what people can do with our product when it's in their hands, because they think of all kinds of things we never would have thought of, right? And so that's a really fun part of the process.
You mentioned your whole of your manufacturing process. There was something in your documentation which caught my eye, which is that you're saying at the same time that you are using established commercially relevant processes, but you have proprietary manufacturing processes. And I'm trying to make sense of those two sentences, how they come together.
Well, there are a lot of things manufactured in this world under commercially relevant processes that are not membranes. And if you apply some of those processes to a membrane manufacturing process, then it becomes novel and innovative and proprietary.
Okay, I see. Where do you manufacture today? How can I picture your plant?
So we are a small startup. And so, this requires large scale equipment. We are doing different processes in different places at different contractors. And so we are producing our own polymers. So that's something we are doing and plan to continue doing for quite a long time. So we make those in-house. We are sourcing our substrate material, which is what we're applying our polymer layer onto. And so we source the substrate, we do the coating of it is a coating, it's a coating of substrate. And then we have our membrane sheet. We can then either sell that membrane sheet directly, or we can take that to a different contractor where they'll roll it into a spiral wound under our specifications and do that. So our manufacturing process is not easy or fast or all of those things right now. Once we have it all in place, a lot of it is standard membrane manufacturing. So we know you can kind of set that as the basis for cost, right? But what's really different is our coating process in terms of how we create our polymer layer versus how the polyamide thin film composite creates their layer. And a big difference is because we make our polymer ahead of time, we have the ability to just lay down that polymer. And so we don't have a lot of really complicated processes with our coating. And that's very different from the polyamides. When the polyamide membranes are formed, they're creating their polymer right there on the surface of the membrane. And so they have a whole lot of leftover materials left off. They've got an aqueous diamine waste stream. they've got an organic acid waste stream. They have to dispose of those when they're done. And so that it's actually quite a large cost. And there's a lot of rinsing tanks and things like that they have to do. So their waste disposal issues when they're done making a polyamide thin film composite membrane are quite high. When we're done, we have membrane. That's it. We have no waste. And so, it's fast. It's very low environmental impact. It's low cost. We can do it very quickly. And our membranes are dry and very stable when they're done. And so that's another factor as well.
You mentioned your process partners, which take your membrane, apply it to the worst possible field, and come back to you flabbergasted, to quote you. Do you know in which field they go, or do they just give you anonymized process parameters? How deep are you into the application?
Primarily where we're seeing a lot of activity is, I would say, in industrial wastewater. And so you might see this in, say, agricultural type wastes. You might see this in textile type waste, semiconductor type waste, lots of industrial waste streams that can be very challenging, mining. So these are kind of some of the areas that people are starting to put these in, which are some of, everyone knows, the most challenging ones. And one of the reasons they're the most challenging is because they have a lot of organics in them. And that those organic things are really tough for the polyamide membranes to deal with. And our membranes, not an issue.
So I was going to say high strength wastewater. So basically the one where you have these high organics, and then it could be across all the industry. So you mentioned food and beverage. Sure. Semiconductor would be probably, again, different type of beast which you have inside, but I also see how that could be a fit. So I was going to say you are catering to the industrial also by design, just because if you go to the municipal desalination, then there's a lot of players which you need to convince that you have something like. It's good to say that they can drop the pre-treatment, but if they have to take some process guarantees and risk management, and we all know that the business model of engineering companies, and no disrespect to them, is to copy-paste because that's the way they build their margin. So you're coming with something different. It's challenging for them to accept even the option of you coming in and changing something. So it sounds like a better fit to the industrial world. I'm curious about your mention of custom development. What examples can you give me of the direction where it's heading? Someone would want unlimited flux, or someone else would want even smaller pores. Or what is the type of changes which you're implementing?
If someone's more interested in very high salt rejection, or if someone's more interested in rejection of, say, organics, and they would rather have higher flux. It's a typical trade-off with membranes is you're going to have, as you go to higher rejection, you get lower flux, higher flux, lower rejection. That's pretty standard. But this is, is one thing that's really important to keep in mind. And one thing some people don't quite relate quite well is that rejection is a general term. Rejecting salt is a very different thing to rejecting organics. And so just because you have a membrane that's 99% rejection, that's spec'd out at sodium chloride rejection. That doesn't mean anything else, right? And so if you have a membrane that's, say, 95% sodium chloride rejection, it's still going to have super high rejection of organics and many other materials. You might have some salts that are rejected at higher percentages than others. And so it gets to, really what are they trying to do with this, and how can we begin to provide a suite of products that we can then target for specific issues that people are trying to solve. That's what we've been doing, is developing kind of a range and providing samples and getting feedback and saying, okay, that worked really well, but they might come back and go, that was great. I love the fact that we could clean it with chlorine, but I wish it had a little bit higher flux. Okay, try this one and see if this works for you, right? In terms of, does this give you all the rejection that you need? It has higher flux. It's just as cleanable. What is it you want? We can make it. It's not an issue.
I have a muggle polymeric question, like for the absolute layman, which I am in that field. I had a conversation with Zwitterco on that microphone, which to me is the other company coming with a new type of material heading now also into reverse osmosis. How different is your technology compared to theirs?
Well, I should preface this with the fact that I have not worked with zwitterionic polymers, and I don't know a whole lot about their membranes. I know very little about their membranes. I know the basis of what a zwitterionic polymer is. I don't know their manufacturing process. I don't know those issues. My understanding is that on the reverse osmosis side, there's zwitterionic polymers a coating on top of a polyamide. And so it still will have many of the traits of the polyamide. It probably has other features because of that coating. But Our material is not that. Our material is standalone material. Our ability to reject salts is going to be very much a function of the composition of the polymer. And we have complete control over that. And we've really gone to market with a product that we feel will be good for industrial wastewater, probably brackish water streams, and maybe a few other things. We think we're going to be quite good in a lot of space where nanofiltration membranes are used. And so we're beginning to do a lot of work in that area as well. But, to be able to have very specific ion rejections or separations, that's something we have the capability to develop because we have this control over the polymer, but that's not where we're working right now. Seawater desalination is another, obviously, something people find very interesting, very valuable. We think we can do that as well. But as you said, that's largely a municipal type application, not where we're focused in our go-to-market right now, because we're going to be able to show the feasibility of this. We're going to be able to show the value of this in the industrial wastewater spaces that we're working. And then, there should be a little bit more buy-in to, hey, let's try it here and be able to optimize the performance once we learn more about, what's the best way to operate it. Everybody's tied into the way we operate systems with polyamide membranes. And there's just no reason to believe that's the only way to do it if you have a different membrane. There's, a whole range of different ways we could do things that could save on costs that wouldn't make any sense at all with a polyamide membrane, but make a whole lot of sense with this new membrane development. So that's kind of what we're looking forward to.
I guess that's your perk of being an outsider to the water industry. You don't know what's impossible, so you just do it, and then it might be working.
That's a good way to put it.
But I think it's very true. I mean, if you've been trained in a certain way to use membranes, then you're going to use membranes that way and believe that's the way, and there's no other way. And if you don't know in the first place how to use the membrane, you're just going to try out and find potentially new ways.
That's right.
I definitely see that, without any joke, as a perk. You mentioned your go-to-market, and you mentioned your partners, process partners, depending on what we want to call them, OEMs, EPC, whatever is the latest acronym in trend. How do you work with them? Is it like an exclusive relationship and then they go distribute your technology? Or do you do kind of integration kits, which then can be adopted by as many people as would be interested or see fit?
Yeah, currently we are not limited to selling membranes to any one particular group. We're really working with companies and people that are innovators. They're the first adopters. They're the ones that are figuring it out. We're beginning to see some signs that some of them are seeing the value, seeing the opportunity, and they're looking for ways to work with us and honestly to help support us, because we're at a very early stage still in our corporate development and we don't have a lot of funds. We don't have a lot of money to work with. And so we're doing it, and we always have done it on the cheap. There's no reason why we have to have fancy offices. There's no reason why we have to have big salaries and tons of people and all that. We're doing this like scientists that have figured out a way to do this. And absolutely, we want to develop a viable business. And I think we're headed in that direction. But, we've had to do this on a shoestring budget. And we've continued in that mindset of how we do things. So we like people that are scrappy. We like to work with people that are interested in trying different things and, see the value in doing new things in a new way and can really make a difference. I think that's how we're going to make a difference. It's those people that we're working with. And obviously, if they're working with us now, they're figuring out how to make it work. They're going to be the ones that are going to be ahead of everybody else when they get out there doing it. So they want to show that, hey, they're the experts in using nanomembranes. That's the way that's going to work out, I'm quite sure.
Now, something I want to pick on, which is you explain how you're bootstrapped and have your limited cash, which is also the reason why I wanted to have that kind of parallel to Zwitcherco, because to me, Zwitcherco would be the other way to go. Zwitcherco is going like massive rounds. They raise about 5 to 6 times more than what you've raised lifetime from nanomembranes. So that's the type of waters you're in. And I had a bit of fun watching your Crunchbase page. I don't know if you ever did that, but Crunchbase has these new indicators of what they predict you'll do. And I would believe they have it all wrong with you. So they say it's very probable that you go IPO. I do hope they're wrong, because it's really not something I would hope for you. But then on the two others, I'm pretty sure they are totally wrong. They say that it is doubtful that you get acquired. I don't get that one, honestly. And the one where I agree is that it's very likely that you get a new funding round. And so I'm wondering, at your stage, I would see honestly two ways. I've predicted that the new ownership of LG Chem will need to add some fancy glow on top of their pretty standard membrane if they want to take it to the next stage and sell it for a premium, which is what private equity does. And if I look at the type of sparkles they can put on top of it, I really scanned the market and thought the best sparkle is you. I'm not pushing you to get married. That's not what I'm up to. But the reverse osmosis market on the membrane end is oligopolistic. You have 3-4 main players. So it kind of limits the type of discussions you have to have if you want to prepare an exit down the road. And exits here in the sense of they're also going to be the ones which can bring you this additional money to get developing and building on the idea. So how, after that very wordy explanation, how important is that in your thought process and in your business operations today to see where you want to take the company? Is it a big funding round? Is it a partnership with a strategic, which doesn't have to be an exit straight away?
That's a great question. We're going to be open to whatever opportunities come our way. We are planning to raise more money. We have an open round currently. We're raising a price round at the moment. Our existing investors are continuing to come in, and we have a strategic customer that's coming in, and we have a few more VCs that would like to come in, but it's not the right time for them. And so we're really looking for a lead for our investment rounds currently. But we're not looking to raise a huge round. We're looking to raise another small round. So we're looking to raise another 5 million. And we feel that 5 million is going to position us for potentially a bigger round at that point, for potentially what we would call a Series A that, might be 10 to 20 million kind of range. I don't see any reason why we have to raise those big rounds. The way we're going about this, it's going to take time to be able to get this membrane into the industry so that people can start to wrap their heads around it. What can we do with this? How can we leverage this? And I think that as we build those stories, as we build those demonstrations, the value of the company is going to grow. And then there may be a reason for an acquisition or a partnership or a bigger round. And, that's where, we want to keep in line with what's a realistic value for what we have. Until we've really demonstrated the value of it, it's all talk. And it's smarter for us to maintain, a lower investment profile while that value is beginning to build. And so the idea is that we're going to build that value well beyond what we will raise so that, there's no doubt, there's no question that, we are bringing value to the industry and we are bringing value to Nella membranes. So whether we end up with an acquisition or owned by private equity or an IPO, what's really important to me, and so it's always been important to me, is really getting this membrane technology out there. If it's going to make the kind of difference that we think it's going to make, which is going to reduce the cost overall of reverse osmosis, make it much less complicated, make it lower environmental impact. Those kinds of things are going to really enable reverse osmosis to do what it has the potential to do, which is solve the world's water crisis. It really does. But right now it's too expensive and it's too limited and it needs to get better. And we think that this membrane will go a long way towards making that happen. And so I want to see that happen no matter what happens to Nella. That vision is very important to me. What we didn't want to do was sell early when we just had a polymer that nobody knew how to make into a membrane. We didn't want to sell it to somebody for some ridiculous amount of money and then they would just put it on a shelf and never do anything with it. So just like we had to figure out how to make it, we've got to figure out how it goes out into the world. When we do all of that, it's going to be a no-brainer. Somebody's probably going to want to buy this because they're going to want to take it even further. And that's what I want to see. So that's great.
Two thoughts. One, which is an impossible question, sorry about that. And then the second, which I promise you is a better question. The impossible question, how do you prove that value? You say you need to prove it, but how?
We're going to prove it with customer demonstrations. We're going to quantify it and it's going to be clear. And I mean, we are so early at this stage and we've only a few early adopters are really jumping on this, but we've got demand well beyond what we can manufacture at this point. And we're building up our manufacturing as fast as we possibly can. And that's why we're building this investment. That's why we're raising this investment, is to be able to take that further faster because we have people that want to try the product. And the more people that try it, the more people are going to find great things they can do with it. And so we've got to be able to make enough to get it out there and demonstrate that. All of those demonstrations are going to add to the value of the company. And that will just position us for the next step.
Which transitions elegantly into my second question, which is there was this call led by Global Water Intelligence and Christopher Gasson, I think 2 weeks ago, to call for a coalition of the willing to push industrial reuse to its next level. And they were simply calling people and say, here's an email, send your email and your applications, and then we'll see. We have no clue where this is heading, but let's gather all the good ideas and let's do something about it. And the premise of that is that today reuse is an idea everybody is on board with, but nobody does at scale, or not to the extent we should, because partially it's too expensive. And
smart.
Yeah. And so that's where it connects to what you said, which is there is a potential, and you might be right or wrong, but if we don't try, we don't know. How could you connect to this kind of initiatives, or said differently, people listening to this, how can they grab you on that ride and team up with you to demonstrate the potential savings which you were teasing in the beginning?
Well, at the risk of being over inundated, call me. We have product. We're making spiral wound elements. We're making membrane sheets, certainly. And people who have ideas about how to use new membranes, who want to try this, we're out there to make it happen. We're not charging exorbitant amounts. We're charging no more than what it costs us to put out the product and get it to people who are going to do something with it. We're looking for partners who have that innovative mindset, that will look at this in a way for, the first time they try it, it might not work out quite right, but come back. Let's talk about it. What didn't work? Maybe you did this and that's not a good idea. And so, we can work with people to do that. And we're building a team to do more and more of that. So we're going to be developing more of that. But like I said, we're working with customers who know how to do this way better than we do. And so we're learning from them in addition to them learning from us. So it's really a partnership. It's a collaborative process to get this done. So it takes the right players. And it's got to be somebody that's, willing to work with us and has the capability to do it and has, something we can fix. And I think there's a lot of things out there we can fix.
You mentioned out there a couple of times, you mentioned the team. You have a particularity which very few companies at your stage have, is that you have a Singapore office. What's the story about that one? Also, because I'm hearing that you're developing with customers which are forward-looking and everything. And usually when I hear forward-looking in combination with water and water reuse, my mind also naturally goes to Singapore. So I'm trying to connect the dots here.
So Singapore, like I said, we've been at this for a while. So when we were developing our thoughts about how are we going to manufacture this, we were looking for partners who could help us with that manufacturing, who weren't the big membrane manufacturers, right? And there was an opportunity to collaborate with a group in Singapore based at NTU. It's the START group. And they have equipment, they have expertise and all of that. And so we engaged with them and began working with them and actually developed a research project that was initiated. We learned a lot from doing that, but we ended up not going that route, and we found an alternative route to get there faster. And that's the way we went. So I'd say that collaboration in Singapore was focused on the opportunity to engage with these partners, but then also to get pilot tests with PUB. That's, everybody wants that, right? In the meantime, we also submitted a grant to NAWI and collaborated with Orange County Water Districts, the American version. And so we ended up kind of pulling back from the Singapore collaboration because we had the opportunities here in the United States, much closer to home. Singapore's a long way from North Carolina, I can tell you that. It's a beautiful place, beautiful people and wonderful people doing great things. But we were able to find the resources that we needed for partners here in the United States. And so we kind of pulled back from that Singapore thrust. And at the same time, we kind of pulled back from that municipal, even potable reuse thrust to focus more in the industrial wastewater space. So we're still working on the potable reuse area. We do still have a project with Orange County, and we're continuing down that path. But in terms of go-to-market, which is where all my energies are focused, Judy's more of the research side. She does the project with Orange County primarily. I'm on the commercial side, and we're all about go-to-market and manufacture and business relationships and all of that. And so that's really where most of our energy is going right now. And so the Singapore pathway, I expect we'll get back there at some time, but today that's not our focus.
Very clear. I could take you on a tangent on that way because I discussed brackish water desalination with David Sedlak when he was on that microphone, but I'll keep that for a sequel down the line. I have a closing question for you in this deep dive. What is your 2030 vision for nanomembranes?
Oh, nanomembranes is going to be everywhere in 2030. We're going to have global manufacturing. We're going to have products in industrial wastewater, seawater desalination, right? It's going to be everywhere. And it's going to be the new thing. The opportunity to work with a new membrane is really great for the early adopters. They think that's great. But once we've got this all figured out, once they've figured it out, it's going to become that me too. And everybody's going to want it. So we look at our challenge is going to be manufacturing materials for the world. So there you go. That's my vision for 2030.
if you reverse engineer that vision, what needs to happen in the next 12 months?
We need to get manufacturing faster.
So that's your bottleneck today. It's the speed of execution.
Yep. Yeah, it's because we don't have control of our manufacturing equipment, and we need to get that control. And that's what we're actively working on, is building that production capacity and bringing down the cost of manufacturing. Cost of manufacturing for us, that's a fun one because we've got so many pieces of low-hanging fruit that are bringing down those costs. And, we anticipate that at scale, our manufacturing processes are not going to be any more expensive than current membrane manufacturing. And we'll be able to sell membranes at value-based pricing. These membranes are going to provide tremendous value to the customer. They're going to last longer. They're going to be easier to use. They're going to lower operating costs and energy and everything. And so, the idea here is that we're going to create a membrane industry with reasonable margins that are not commoditized, that actually has a margin that's appropriate to the value of the product. And everyone's happy with that because it works for everyone. So I don't anticipate membrane costs going up tremendously. I expect we will be selling them a little bit more than these commoditized membranes, but not anything near what the value they're going to be getting out of these. So everybody's going to win here. That's the idea.
And to get that better hold of the manufacturing and to go faster and reduce your manufacturing costs, that's the reason why you're raising the money right now?
Yes.
And doing a small round will be sufficient for that?
Yes.
You're really bootstrapped. But you mentioned how you already have your existing investors, which are continuing investments. Are you looking for a lead investor? What's the profile of that lead if you have to just do an open call?
I think probably a clean tech investor, a primary opportunity, or a strategic. We don't want to get too deep with anybody in terms of, limiting access to our technology, but there are definitely some strategic that could work with us and partner with us along that way to get us to the point that matters. But I think a clean tech investor would be fantastic, preferably somebody that's ready to move, because I'm ready to move.
Very clear. Well, Sue, it's been a pleasure to have that deep dive with you. If it's fine with you, I'm rounding off these conversations with a rapid fire question section.
I'm not good at those, but we'll see.
It's time for the rapid fire questions.
What is the toughest challenge in your opinion for a water tech startup?
I think the incumbency is quite challenging just because the industry is very set in its ways, and especially on the membrane side, people don't even know what you mean by a new membrane. They just can't even fathom it because it's been so long since they've had anything different.
So I told you about the sidetracks. When I was at Suez, I was working for the department which was containing Aquasource. And so I've been to Aquasource's production site like on a monthly basis, and I've seen those cellulose acetate lines producing, and I've seen them closing and switching to a different material. So I get the point that this industry is not the most ripe for a disruption and doesn't really like to change stuff. But when a superior material comes around the corner, it also ultimately reaches a tipping point where it gets adopted. So I would have some level of optimism there that it can happen. I've seen it happen in my professional lifetime, so I guess it can happen again.
I think it will. I think that, one of the things, it's actually a challenge we've dealt with from the very, very beginning, is that because we're polymer chemists, we understand that a new material has different characteristics, right? A lot of people don't. Like you said, they don't understand what's different in a polymer. It's like plastic's plastic, right? And so, trying to, people, even though you say, look, it's a different material, it's not a polyamide, you need to think of it differently. They go, okay. And then they just put themselves right back into that box. And we might even like professionals, like scientific people, like we'll convince them, we'll get them over here where they're like, okay, they're starting to see outside that box. And then, the very next day they come back and they're back in the box. It's like, you got it. It's really challenging for people who are so used to the way you use polyamides to do something differently. They just have a really hard time wrapping their heads around it. And so it's just going to have to be shown. And that's what we're trying to do.
What would be your best single piece of advice for the founders and managers of the about 1,000 early stage water startups?
Prepare for delays. Everything takes so long. We've had to learn to be more patient and keep working through it. I think persistence is so important, to keep trying and keep working on it. And no doesn't necessarily mean no. It means not now. And okay, so how can we do it? And what should we do if that's not going to work? How can we get there, right? So I think patience and just be prepared for long cycles of trying to get things done.
What's the drop of knowledge you wish more investors knew about the water sector?
I think that a lot of investors, they look at the commoditization of the market and they say, oh, nobody's going to change. This product isn't worth anything. And I said, I keep trying to tell them, I'm like, no. And Randy Truby works with us. And his big thing is he says, water companies, they love innovation. They love new technology. They'll try it. And if it's better, they'll buy it. And so I think that's something that I would like investors to understand, because a lot of them feel like we're never going to be able to get anybody to try something new. They just don't understand how different this is, and the opportunity that it provides really gets people moving to try things. Especially, we're doing things with our membranes that you can't do with polyimide membranes. I mean, we're like literally replacing thermal distillation, or take it away and put it in a hole with a membrane process. That's something that hasn't been done in a long time, right? Because people made the polyimides work. They don't work for everything, and they're not cost effective for everything. This works in places that doesn't. And that's something the investors don't understand. I think most investors don't understand how much wastewater is in this world. And the more we make stuff, the more wastewater we make. And we don't have good ways of dealing with that wastewater. The way we've done it before is dump it in the river and say, dilution is the solution to pollution. That's not working for us anymore. It's going to get worse. We've been doing that for a long time. The water is getting worse, and we're going to have to be able to treat all that water. How are we going to do it? With nano membrane.
There's again so much I could unpack in what you just said, just because there's still half of the wastewater in the world which is not treated at all. And I'm not even talking of an environmental perspective. I'm just talking of a pure wasted resource. I mean, when we say that 50 billion of economic worth is going to be destroyed by 2040 just because of water scarcity, well, there you have it. It's just there, and we don't use it. So that's one thing. The other thing is membranes in the 90s were looked at something absolutely stupid. Like, who would ever try to use that thing? It's too expensive. It's never going to work. And within 30 years, which has never been seen in this industry, it has taken over almost every field, to an extent that a water professional like me believes it's already in every field. And what you just said is so true. It's that there are so many additional fields where we don't use membranes yet, just because they have limitations. But if now you take the perks of the membranes to that field as well, then there's a reason why membrane technology took over so many applications. It's because they offer perks which other processes can't. But I can't open every sidetrack, so let me keep it at that. What's your most unexpected partnership, and what did it bring you?
Oh, I would say Randy Truby. Randy, he just kind of showed up. That I was looking for some help, and I asked a few people, hey, who could I get to give us some industry experience? And I must have had 3 or 4 people say, oh, you should talk to Randy Truby. You should talk to Randy Truby. I said, well, fine. Will somebody give me his number? So I called him, and we just hit it off really well. And he saw value in what we were doing and thought it was interesting and exciting. And I think we've kept him entertained. And so he's on board. And that was surprising how interested he was and how much he's contributed to us. He's become an integral part of our team, and we love having him as part of the team. So I'd say that was a huge benefit to our company.
Super short, profitability or growth?
We need both.
I don't come with profitable growth. Everybody answers me that. You have to pick one.
So yeah, I'll tell you what we're doing. Right now we're growing as we keep moving towards profitability. And my goal as the CEO is to move us to profitability as quickly as possible while we grow to meet the market that's ahead of us. So growth has to happen because the demand is high, and we've got to find that balance. But a lot of the money that we're raising is going into manufacturing product that is being sold at less than it costs us to make it, right? Because we need to grow. We need to get it out there and demonstrate what it can do. But our march to profitability is quite rapid, and I intend to make that happen so that we can be profitable and grow at the same time.
What is the next profile you'll hire?
Well, we actually just hired a few people, but I think we will probably be hiring more in the applications engineering area. We're also going to be bringing on a full-time CFO in the near future. We've been working with a fractional CFO who's fantastic, but he said we're outgrowing him, so we're going to have to go get our own, and we're going to have to let him go, which is unfortunate. I'd not let him go. I'm going to have to let him go because he's leaving, not because I'm letting him go. I would try to hang on to him if I could. But I think applications engineering is super important because, again, that's not our skill set, and that's something that right now we're relying on our customers for, and that's not going to be a growth strategy. We're going to have that internal to be able to get that going.
Which is a trend that I noticed in lots of membrane companies. I mean, the last time I had that conversation was with Embryon, where they looked at the team and said, okay, we have great people, incredible brains, but our share of people who understand water, which is where we apply our stuff, is not high enough. So that's where we need to beef up. And it seems to be like a trend which makes sense.
Right.
When you look for these application people, do you look for people coming from the water industry or people coming from startups?
Yeah, that's a good question. I think probably from the water industry is where I'm going to be looking. But as I was saying earlier, it's going to be really important to make sure that we find somebody who isn't so stuck on polyamides, that's, willing to work outside the box, do things differently, and have that creative, innovative mindset. They have to have that. They can't be just stuck in that this is what we've always done, this is what we have to do. So I think that's going to be our challenge in finding, someone who has that ability to work outside where they have worked before, because they will have never worked here before.
Opening new markets or doubling down on the current ones?
Yeah, we're doubling down on industrial wastewater right now. That's definitely what we're doing.
What is that tool nobody speaks about, but you could not live without?
I think probably the synthesis people, right? The people who make the polymers. And that's a unique skill. Not everybody can do that. Even polymer chemists. We all know there's some of us that are just better at that than others. And so having those highly skilled polymer chemists to create those materials effectively is really important. And Judy is a phenomenal polymer chemist, and her creativity and her ability to apply her knowledge to developing new materials, idealizing what could be done is really great. But you also need that person in the lab, in the manufacturing facility who can actually do it. And that can take some special skills. It's one of those things that, yes, it's a science, but yeah, there's got to be some technique and some art in there as well.
You mentioned your early adopters, which you're looking for. So if they are listening to you right now, what is the single piece of insight your ideal customer profile needs to hear right now?
Trying things. If they're willing to try something that's different, they're having a problem with fouling of their membranes, come talk to us, because we have a very different fouling profile for both organics and salts. And so, the opportunity to really change the issues that they have to something much easier to solve is a direction that I think we can go. And so, if they're willing to try it, we're willing to help them.
What are you desperately needing and want to raise an open call for right now?
I honestly need money at this point. You give me the money, I got a plan, and we're going to go hit it hard. And I need that money in my hands so I can do some good with it, because I've got a lot of things to do with it.
And final question, what can and should I do for you?
I appreciate you bringing me on here and talking to me. I value your interest. You clearly are interested. I like the excitement about new things and, what's going on in the industry. I'm also quite intrigued by what's going on in the industry. I think we're seeing a change. I think things are starting to happen, and I'm excited to see that. I'm excited to be part of it. And so I really appreciate you bringing us on here, and hopefully we'll be able to get this out to some people that maybe haven't seen us before, maybe haven't heard about us before, and get this thing to the next stage, because this is a fun time to be in this industry, I think.
I'm nobody and I can't promise anything. It's just when I'm speaking with investors and I hear repeatedly that lots of people who don't really understand the sector come to the ones which understand the sector and say, where can I park some hundreds of millions? And on the other hand, I speak with great companies, which honestly, I generally get excited for companies when I generally believe that they have a perk and something which they bring to the market. And when I see that you're looking for money and then money is looking for clever tech, and it seems to be a disconnect, it's something I really don't get, honestly, because it sounds obvious that if you put gasoline on the fire, it's going to burn. So yeah, if that's you listening to it, you can reach out to Sue, or if you want to reach out to me to know off record why I'm excited, happy to have that conversation as well. So if people want to follow up with you, where should I redirect them the best?
My email is a great place to go. Our website is nalamembranes.com. My email is sjmeekum@membranes.com. So happy to look for new opportunities to deploy our membranes, and obviously people who would like to invest and partner with us. We're going places, and we need some partners to go with us.
As always, the links to all of that are in the description, so just check them out. And Sue, again, thanks a lot. And I hope to have a sequel with you in 1 or 2 years, because at that part, you're going to be ahead of your path toward domination. So I'm looking forward to that.
Sounds good. Me too.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.